In this lesson, we'll talk about the most fundamental rule of differential calculus. It's called the chain rule. See, whenever you take the derivative of a function, you are using the chain rule. Whether you notice it or not, you are using the chain rule. Wait a minute. You're probably thinking, what if I take the derivative of, say, x to the power of 10? Now, is the chain rule involved here? Let's talk about that. In the previous lesson, we learned that whenever you see a power function, right, something like this, x to a power of 10, or x to a power of 5, or say 6x to a power of, say, 8. Now, to find the derivative for any power functions, we simply apply the power rule, right? The power rule to help us find the derivative. So in this case, derivative of x to the power of 10 is 10x to the power of exponent minus 1. That's 9, right? Right? See, remember the power rule. We bring the exponent to the front, so 10. And afterwards, exponent minus 1, so we get 9. Right? Same here. So now bring the exponent to the front, so we have 5 in the front, x. Now exponent minus 1, we get 4. Right? Power rule. Same here. Bring exponent to the front, so we have 8, but we got to multiply by 6 in the front, right? So bring 8 to the front times 6, we have 48. X. Now exponent minus 1, we get 7. Right? That's easy. Power rule. In fact, we were able to find the derivatives for this function without knowing this thing called chain rule. And now I'm telling you chain rule is everywhere in the world of differential calculus. Am I crazy? No, I'm not crazy, but now let's really talk about the chain rule, the king of differential calculus. As mighty as the chain rule sounds, this is what it comes down to. If y is defined as a function f of something. Now, to differentiate this function, we get f prime of that something and followed by the derivative of that something. And guys, chain rule. Why do we call it the chain rule? Because there's always this little part at the end being chained. Imagine there's a chain being chained to the derivative of the function. And that's why we call it the chain rule. Okay? Guys, I understand. This expression might look kind of weird to you at this point, but trust me, in a moment, you will grow to love this very, very much. Okay? And just so you know, the official definition from the textbook, you will often see something like this. The derivative of a composite function, f of, now inside the bracket, we have another function, g of x. So the derivative of this whole thing is, now you take this whole thing, copy down this whole thing, f of, now inside, same thing, the g function. But now, we gotta have a prime here, indicating that we are taking the derivative. Now, why do we call it the chain rule? Because we always gotta have this expression followed by this little guy, right? So the derivative of whatever inside the function. In this case, we have g of x, right? Guys, remember, we always need to have this little part being chained to the derivative of the function. And that's why we call it the chain rule. The chain rule definition here is the simplified version that I personally come up with. The reason I prefer this simplified version is it allows me to put whatever I want inside the bracket. See, it could be a simple x, then inside the bracket here would just be x, inside the bracket here would just be x. It could be a trigonometry function, say sine x. Now inside the bracket would just be sine x, inside the bracket here, sine x. Simple as that. And it can be a, say, exponential function, e to the power of x, then inside the bracket here and here, same thing, e to the power of x, e to the power of x, right? It could even be like a little crazy star. Then inside the bracket, I just put a crazy star and a crazy star. See, whatever you put inside the bracket the chain rule works in every single way. Now, without further ado, let me show you how to use the chain rule to conquer the world of differential calculus. Let's go. In this question, we're going to differentiate two functions. First function, y equals x to the power of 10. Second function, y equals this long polynomial to the power of 10. Now, these two functions might look very different. Because if we were to expand the second function, taking this long polynomial to the power of 10, we'll end up with a super long and ugly polynomial that starts with this term, x to the power of 50, and so on, right? However, in the eyes of chain rule, for finding their derivatives, these two functions are pretty much the same. And let me show you what I mean. Here, I'm going to differentiate the first function on this side of the board, differentiate the second function on this side of the board, so that you can see how the chain rule works in similar fashion in both cases. Cool. So start with the first function. Y equals x to the power of 10. Guys, would you say this is the type of function we came across very often in the previous lesson when we learned the power rule to find the derivatives, right? Yeah. See, here we have a power function, x to the power of 10. So let's use the power rule to differentiate this function. So the derivative y prime is equal to, now power rule is very easy to apply. We simply bring the exponent to the front, 10. Okay, now. And then the exponent for x, what do we have to do? We have to subtract 1 from the original exponent. So if the original exponent is 10, we simply subtract 1, right? So the derivative of this function is 10x to the power of 10 minus 1. That's 9. Okay? So as you can see, we were able to find the derivative of this function by using the power rule and the power rule only. See? Without using the chain rule. So remember, just now we talked about how chain rule is everywhere, right? Whenever you find the derivative of a function, you are using the chain rule. See, whether you notice it or not, you are using it. But how come it's okay for us to not use the chain rule in this particular case? See, now, let's say for question B, if you simply use the power rule to find the derivative of the function without using the chain rule, you get the answer wrong. But how come in this case it is okay? Well, you know what? Let me use the chain rule to do the exact same question, and then you'll see why. The trick for applying the chain rule is to use the bracket technique, as we discussed earlier, right? So the derivative of the function f bracket is f prime bracket followed by derivative of the bracket. See, this is chain rule. Because we always want to have this little guy at the end being chained to the derivative of the function, right? Yeah. So now, let's use the bracket technique. So I'm going to bracket the variable x. Okay. In fact, at this point, I don't even want you to see the thing inside the bracket. Okay. You know what? I'm going to block it so you cannot see it. Yeah, let me block it. Good. So now you cannot see the thing inside the bracket, okay? Because I want you to focus on the bracket. Cool. So let me ask you, what kind of function do you see here? Well, it's a power function because we have a bracket to the power of 10. So whenever we see a power function, how do we find the derivative? We use the power rule, right? Yeah, so let's use the power rule as before. So to find the derivative, y prime is equal to, so power rule tells us that we can bring the exponent to the front. So bring 10 to the front, bracket. Now what do we do with it? What do we do with the exponent? We have to subtract 1 from the original exponent, right? So we have 10 minus 1. And guys, don't forget, what's chain rule? You always gotta follow by derivative of the bracket. And that's chain rule, right? Cool. Now, so guys, now I have to determine what is that thing inside the bracket, right? So I'm going to remove the block, and I'm about to reveal what's inside the bracket. Okay? Cool. Are you guys ready? Let's go. Move this away. Ta-da! Ah, so turns out the thing inside the bracket is just a simple x. So the thing inside the bracket is an x. So we put x inside the bracket, we put x inside the bracket. See, that's the beauty about the bracket technique. Very simple. See, now, guys, if I move the block away and turns out inside the bracket we have a sine x, no big deal. If this is sine x, we just put sine x inside the bracket, we put sine x inside the bracket, right? Yeah. Cool. Now, check this out. So let's clean things up. So here we have 10x to the power of 10 minus 1, that's 9. Times, well, guys, now, what is this guy here? What is this guy here? Well, guys, let me ask you, what's the meaning of derivative? Slope of a function, right? Derivative is nothing but talking about the slope of a function. So now, what is the slope of the function x? So if we have a function just x, well, you know how to graph this function, right? Y equals x, the function is simply a straight line, right? And what's the slope for this straight line? 1, right? So the slope of the function x is just equal to 1. Yeah? And guys, you know what? Let me show you another way to think about this. It's a bit easier. Okay? Guys, let me ask you this. What's the value for this guy right here? ddx of x. Because, now let me put it this way. If I were to ask you 5 over 3 times 2, you'd be like, oh, that's easy. That's a no-brainer. The answer is, I'm going to multiply 2 to the numerator. So 5 times 2, and then divided by 3. So the final answer is 10 over 3, right? So guys, in similar fashion, let's also multiply this x to the numerator. So then we have what? dx, right? Multiply x to the numerator over dx. And guys, whenever we have the same thing for numerator and denominator, that's going to give us a value of 1, right? You get it? It's like this. What's 8 over 8? That's 1. What's 80 over 80? That's 1. What's 8,000 over 8,000? That is still 1, right? So whenever we have the same thing for numerator and denominator, we get a value of 1. Ah. So here, dx over dx is 1. Ah, okay. So now, so the final answer we have 10 to the power of x, 10x to the power of 9 times 1 is just 10x to the power of 9, right? Because anything times 1 is just itself, right? Because times 1, nothing changes. Now, hey guys, now do you guys see why chain rule is optional in this particular example here? I mean, guys, whenever you take the derivative of a function, you are using chain rule. Whether you notice it or not, you are using it, right? So we always have to use chain rule, but in this particular case, chain rule becomes optional. See, the first time around, we didn't use chain rule. We only used the power rule alone. We got this answer. See, we still got the right answer without using the chain rule. Now, you see why it is okay to, in this particular case, to not use the chain rule? It's because the variable we are dealing with here is x, right? Now when you put x inside the bracket, dx over dx is 1. That's why. Okay, guys. So that means, guys, if inside the bracket we don't have a simple x, if we have, say, what happens if we have 2x instead of just a simple x? If we just have 2x. Now, can you ignore the chain rule? No. You know why? Because now, if you put 2x in the bracket here, that will give you a value. Well, guys, what's the derivative of 2x? That would be 2, right? Guys, so guys, you cannot ignore 2. Because anything times by 2 actually doubles the value, right? Yeah, see? Is that cool? So that's why. The only time you can choose to ignore the chain rule is when you have x inside the bracket, okay? And why is that? Because the derivative of x is 1, and anything multiplied by 1 doesn't really change anything, okay? Cool. Question B, differentiate the function y equals this polynomial to the power of 10. Now, to the power of 10, that means we're dealing with a power function. So what we want to do is, inside the power, let's put a bracket. Okay, now you got to ask yourself, are we going to be able to get away with not using the chain rule, like here, in this case? Well, guys, the only time we can possibly get away with not using the chain rule is what? Is when inside the bracket, we just have a simple x, right? Now, look at this question here. Inside the bracket, do we just have a simple x? No. We actually have a pretty complex polynomial inside the bracket, right? So guess what? We have to use chain rule. Okay? Cool. So now, guys, before we apply the chain rule, I like to block whatever inside the bracket because I don't want this thing to distract you when we apply the chain rule. Okay? So don't look at this thing inside the bracket. So let me block it. Nice. Cool. So now, let's apply the chain rule. Okay? So to differentiate this function, we get y prime is equal to, guys, what's the derivative of bracket to the power of 10? Well, let's apply the power rule, right? So power rule tells us that we can bring the exponent to the front. So that would be 10 bracket. Now, what do you do with the exponent? We have to subtract 1 from the original exponent. So we go 10 minus 1. And guys, chain rule, that means there's always this little guy at the end, right? The little guy at the end is always the derivative of the bracket, right? Remember, we always need this guy at the end because this guy is chained to the derivative function, right? Cool. Now, guys, now that we finished setting up the chain rule, now it's the time to reveal what's inside the bracket. Okay, so let's remove the block. So turns out the thing inside the bracket is this guy right here. Okay, so it's x to the power of 5 plus 4x cubed plus 6x, minus 6x and then plus 8, right? So the thing inside the bracket, once again, is x to the power of 5 plus 4x cubed minus 6x plus 8. Right, guys? Now the rest is easy, right? So now we just have to clean things up. So y prime is equal to 10 to the power of 10 times bracket to the power of 10 minus 1. That's the exponent now is 9, right? And inside the bracket, we have this guy. So just copy the same thing down here. So x to the power of 5 plus 4x cubed minus 6x plus 8. Okay, now, guys, now is the time to take derivative of this guy right here, right? So guys, what's the derivative of this polynomial function? Well, that's easy, right? We just have to apply power rule again, okay? So now derivative of, let's do this. Okay, first term. what's the derivative of x to the power of 5? Applying the power rule, we get 5x to the power of 4, right? Now, plus, what's the derivative of positive 4x cubed? Well, bring the 3 to the front and times by 4, we get what? 12, right? X, exponent minus 1, so 3 minus 1, we get 2. Okay? Now, what's the derivative of negative 6x? That's just what? That's just negative 6, right? Oh, by the way, even that you can apply the power rule. Let me show you. Derivative of negative 6x. Let me show you how you can actually apply the power rule in this case as well. I mean, you can memorize it. Derivative of a number in front of x is just that number. But now you can also use the power rule to understand it so you don't have to memorize anything, right? So guys, here it is. Now, okay, here we have x to the power of what? 1, right? So guys, check this out. We can bring 1 to the front, right? Bring 1 to the front and multiply by this number, negative 6. We still get negative 6, right? Now, x. Now remember, guys, the original exponent, we must what? Subtract 1, right? Now, this we will have negative 6, x to the power of, guys, 1 minus 1 is 0, right? And guys, negative 6 times anything to the power of 0 is 1. Okay, so the answer is negative 6. Okay, guys? Cool. So the derivative of negative 6x is just negative 6, right? Very cool. Now, yeah. Now at the end, what's the derivative of the constant number, positive a? Derivative of any constant is 0, right? Right here. Derivative of any constant number is 0, right? Yeah. So that's just 0. And with 0, we actually don't have to write it out, right? Okay. And guess what, guys? That's it. That's it. This is the derivative of this function. Okay? Now, guys, remember we said in the eyes of chain rule, for finding the derivatives for these two functions, these two functions are pretty much the exact same thing in the eyes of chain rule, right? Isn't it? Check this out, guys. Look. Okay. Look how we set up the chain rule for question A. We have 10 times bracket to the power of 10 minus 1. See? 10 times bracket to the power of 10 minus 1. Yeah? And followed by what? The derivative of the bracket. Followed by derivative of the bracket. Yeah? See, in the eyes of chain rule, these two functions are pretty much exactly the same, right? When we find the derivative. Now, the only difference is what? Is the stuff we put inside the bracket. See? Now, for question A, the thing we put inside the bracket is x. See? Now, for question B, the thing we put inside the bracket is this guy. Right? That's the only difference. But everything else is pretty much the same, right? Yeah.